Hi children, we continue with our fifth chapter, periodic classification of elements. In the previous class, we discussed two earlier attempts at the classification of elements, Dobereiner's triads and Newland's law of octaves. Now, today we move on to the third attempt at the classification of elements, that is Mendeleev's periodic table. Mendeleev's periodic table. Dmitry Ivanovich Mendeleev, a Russian chemist, he made a major contribution to the early development of periodic table. And this Mendeleev, Dmitry Ivanovich Mendeleev, he is considered as the father of periodic table. Actually, we are not using his periodic table currently. We are using the modern periodic table, but the title father of periodic table is given to Mendeleev because he made major contribution in the early development of the periodic table. So at the time of Mendeleev also, atomic mass was considered as the basis of classification, fundamental property of an atom. So it was considered as the basis of classification. Elements were arranged in the increasing order of atomic mass. In his periodic table also, we can see that elements are arranged in the increasing order of atomic mass. He also studied the properties of elements. Not only physical properties but also chemical properties. He prepared the oxides and hydrides of each and every element. At the time of Mendeleev, 63 elements were known. So, he prepared the oxides and hydrides of these elements and studied their properties. And the elements whose physical and chemical properties are similar, they were grouped together. The elements with similar physical and chemical properties, they were grouped together. Actually, what is the advantage of this grouping? We need not learn individually each and every element. We need not learn the properties of each and every element individually. Instead, we need to learn the properties of that group only. All the elements coming under one group, they will have same properties. So that is the advantage of grouping or classification. We need not learn individually, we need not learn all the elements, properties of all the elements. Instead, we can learn the properties of one particular group. Then that includes the properties of all elements under that group. Okay. So, he arranged the then known 63 elements. At the time of Mendeleev, 63 elements were known. So, he arranged the then known elements in the increasing order of atomic mass. So, he grouped elements based on their similarity in physical and chemical properties. Elements with similar physical and chemical properties. In order to study the chemical property, he even prepared the oxides and hydrides of these elements existing at that time. And he came up with his periodic law, Mendeleev's periodic law. The law states that physical and chemical properties of elements are periodic functions of their atomic mass. Periodic function. What do you mean by periodic function? So, Mendeleev's periodic law is physical and chemical properties of elements are periodic functions of their atomic mass. What do you mean by a periodic function? What is the meaning of the term periodic? Periodic means something which repeats at regular intervals. A periodic function means a function which repeats at regular intervals. Periodic motion you might have learned, periodic motion. So, the term periodic refers to something which repeats at regular intervals. Actually, you have to state the law in the correct way as it is given in the book. The physical and chemical properties of elements are periodic functions of their atomic mass. But the meaning is that, please listen, when elements are arranged in the increasing order of atomic mass, the elements with similar physical and chemical properties repeat at regular intervals. That is the meaning of this statement. Elements with similar properties will be repeated at regular intervals. So, under one column in the classification, you will see elements with same properties. So, you need not learn each and every element individually. We have to learn the properties of one column. Properties of all the elements in one column. They will have same properties. So, properties repeat at regular intervals. Elements with same properties repeat at regular intervals. That's what meant by periodic function. Properties are periodic functions of their atomic mass. So, what is Mendeleev's periodic law? The physical and chemical properties of elements are periodic functions of their atomic masses. And in the Mendeleev's periodic table, there are vertical columns. What do you mean by vertical column? Going down, this is vertical column. We call it as group. And the horizontal rows are known as periods. So, in the Mendeleev's periodic table, there are vertical columns known as groups and horizontal rows known as periods. So, please look at table 5.4. Please take table 5.4 in page number 83. Page number 83, table 5.4. So, you can see the Mendeleev's periodic table. On the top, you can see the group numbers 1, 2, 3, 4, 5 like that. Roman numeral, what is given is group number. So, all the elements coming under group 1, they will have same properties. And also you can see that all elements of group 1, what is the general formula of their oxide? R2O, where R stands for the element. So, if it is lithium, oxide will be Li2O. And all the hydrides of that group will have general formula RH. R stands for the symbol of the element. Similarly, for group 2, you can see that all the elements, all the oxides of all the elements of that group, they will have the general formula RO, and hydrides will be RH2, where R stands for the symbol of the element. Same is the case with all the groups. How many groups are there? 8 groups. So, these groups, vertical columns are known as groups, and the horizontal rows are known as periods. Okay, now we have to learn the merits. In the other earlier attempts, we learned only the demerit or drawback. Here we have to learn the merits of Mendeleev's classification. Merits of Mendeleev's classification, that is the next topic. Merits. So, first merit is, he left gaps in his periodic table. This Mendeleev was sure that there are more elements to be discovered in future. That was one of the drawbacks of Newlands. He believed that only 56 elements exist in nature. But Mendeleev knew that there are more elements to be discovered in future. So, he even left gaps in his periodic table for the elements to be discovered later. So, he left gaps in his periodic table for the undiscovered elements, and also he even predicted their properties. He left gaps. He not only left gaps in his periodic table, he even predicted the properties of these undiscovered elements. How can he predict? How could he predict the properties of undiscovered elements? There are other elements in the same group. Based on the properties of other elements of the same group, he even predicted the properties of these undiscovered elements. That is one of the most important achievement of Mendeleev's periodic table. So, it can be considered as an achievement of Mendeleev's periodic table. He left gaps in his periodic table for the undiscovered elements, and he even predicted the properties of these elements based on the properties of other elements of the same group. He left one gap under boron, one under aluminium, one under silicon. He called these undiscovered, one gap under boron, one gap under aluminium, one gap under silicon. He called these elements as Eka boron, Eka aluminium, Eka silicon respectively. He called them as Eka boron, Eka aluminium, Eka silicon. Later on, these elements were, when these elements were discovered, they were called scandium, gallium and germanium respectively, and they had exactly the same properties as predicted by Mendeleev. That is the first achievement of Mendeleev's periodic table. He left gaps in his periodic table for the undiscovered elements, and he even predicted the properties of these elements. He left one gap under boron, one under aluminium, one under silicon, and he called these elements as Eka boron, Eka aluminium and Eka silicon. Later, when these elements were discovered, they were named as scandium, gallium and germanium respectively, and they had exactly the same properties as predicted by Mendeleev. Okay, that is the first achievement or first merit of Mendeleev's periodic table. Second one was noble gases. Helium, neon, argon, krypton, xenon and radon. That group of noble gases were not discovered at the time of Mendeleev. When the Mendeleev's periodic table was made, these noble gases were not discovered. Later when these elements were discovered, they could be placed in a separate group. At the end, these elements could be placed in a separate group without altering the existing order of elements. Without altering the existing system, they could be placed in a separate group, and this group was named as zero group. This group was called zero group. And the third achievement is that when his periodic table was made, there were a few instances where Mendeleev had to place element with slightly higher atomic mass before an element with slightly lower atomic mass. Actually, Mendeleev's periodic table is based on atomic mass. Elements are arranged in the increasing order of atomic mass. So, at certain places, he even inverted the order of atomic mass. Element with higher atomic mass, slightly higher atomic mass was placed before an element with slightly lower atomic mass. This was done in order to give more importance to similarities in properties. Elements with similar properties could be grouped together. So, in order to give importance to that, he even inverted the order of atomic mass. A few such pairs, we call it as anomalous pairs, where element with slightly higher atomic mass comes before an element with slightly lower atomic mass. Please take group 3 and 4. Look at group 3 and 4. In the third period, you can see aluminum and silicon. Aluminum atomic mass is 29.98. Silicon, it is 28.09. So, aluminum has higher atomic mass than silicon, but aluminum is placed before. So, aluminum resembles these other elements of that group like boron, gallium, etc. So, in order to give more importance to similarities in properties, he even inverted the order of atomic mass at certain places. Then in the last group, cobalt and nickel, you can see cobalt is having atomic mass of 58.9, nickel it is 58.7 only. So, nickel should appear before cobalt, but that order is reversed so that properties, similarity in properties should be maintained. So, he gave more importance to similarities in properties than the increasing order of atomic mass. In the modern periodic table also, you can see that aluminum comes before silicon, cobalt comes before nickel. So, the prediction of Mendeleev was correct. He gave more importance to when atomic number was made as the basis of classification, this grouping was found to be correct. Okay. So, these are the three achievements or three merits of Mendeleev's classification. First one is he left gaps for undiscovered elements and predicted their properties. For scandium, gallium and germanium, he left gaps and they had exactly same properties as predicted by Mendeleev. Then second one, noble gases were not known at that time. So, when they were discovered, they could be placed in a separate group without altering the existing order. Then third one is at certain places, certain cases he had to invert the order of atomic mass in order to give more importance to similarities in properties. A few examples, one or two examples, aluminum and silicon you can write, one such pair where mass is altered to give more importance to similarities in properties, cobalt and nickel. So, these are the achievements. Now, there were two demerits also, two drawbacks also. First one is that hydrogen, the element hydrogen, actually hydrogen is a unique element, though it is the lightest element, it has certain special properties. Hydrogen shows resemblances to group 1 elements, elements in group 1 which are known as alkali metals, and elements in group 7 halogens. This is group 1 elements. This is group 7 elements. So, hydrogen shows resemblances to elements in group 1 alkali metals and also elements in group 7 halogens. So, there was a confusion where to place hydrogen along with alkali metals or with halogens. He placed hydrogen. Finally, Mendeleev placed hydrogen along with alkali metals in group 1. As the name suggests, it is a group of metals. Lithium, sodium, potassium, etc. All the other members of group 1 are metals. Hydrogen is a non-metal. So, this is considered as a drawback of Mendeleev's classification. It showed resemblances to both group 1 elements and group 7 elements, alkali metals and halogens. He solved this problem by placing hydrogen along with alkali metals in group 1. But hydrogen is not similar to alkali metals in all its properties. This problem was there in the modern periodic table also. They solved it by giving hydrogen a unique place, a separate place. Hydrogen is not included in any of the groups in the modern periodic table. So, this is actually a small mistake by Mendeleev. He placed hydrogen along with alkali metals in group 1. The second drawback is that the position of isotopes couldn't be explained with Mendeleev's periodic table. Position of isotopes. What are isotopes? Isotopes are atoms of the same element with same atomic number but different mass numbers. So, position of isotopes couldn't be explained. For example, hydrogen. Hydrogen has 3 isotopes. Last year you have learned. One with mass number 1, other one with mass number 2. This is how they are written. H11, H12, prosium, deuterium and tritium. These are the 3 isotopes of hydrogen. All have same atomic number but masses different 1, 2, 3. So, if the order of atomic mass is strictly followed, all of them should get separate positions in the periodic table. That is not done. So, position of isotopes couldn't be explained. These are the 2 drawbacks or demerits of Mendeleev's periodic table. Okay, one is position of hydrogen. Hydrogen was given position along with alkali metals in group 1. But hydrogen is not similar to alkali metals in all its properties. It resembles halogens also in its properties. Second one, position of isotopes couldn't be explained. So, that's all. Thank you, children.